All right, in this first set of videos, we're going to talk a little bit about the simple experiment. This is, as we will see, the basic type of experiment upon which other models of experiment are built. So in these first few weeks, we're going to talk about experimental design. And then in the second half of the semester, we're going to talk much more about the analysis of data from these. So we'll talk about how you'd go about analyzing data from the simple experiment. And as a spoiler, that's going to be the t-test. But in these videos, we're going to talk about a few things. First, in this first video, I want to talk some about the basic logic and the terminology around a simple experiment. We'll also spend a little bit of time in this video and mostly in the next video talking about errors and determining whether or not the results from a simple experiment are statistically significant. Then we'll say a little bit about statistics and the design of a simple experiment, but the statistics, like I said, for the most part, are going to wait until the second portion of class. We'll talk about some non-statistical considerations in how you design a simple experiment. In other words, what types or forms of experiment are considered to be more valid or less valid. And then finally, we'll say just a little bit about analyzing data, but that is going to be reserved mostly for the next unit where we'll dive deeper into statistics. So when it comes to the basic logic and terminology, there's a few terms that you should have in the back of your mind. We talked some about these last semester, but they're worth bringing back up again. The first one is hypotheses. Remember, your hypothesis about what's going to go on in the world, and especially what's going to go on with participants in your study, are really going to determine the structure of your study. These hypotheses need to be specific and they need to include operationalized variables. So operationalized variables, remember, are the way in which you take a construct like happiness and either measure it, like a self-report inventory of happiness, or manipulate it, like have people watch a video designed to make people feel happier. So your hypotheses need to have these operationalized variables. Next, for experiments, you need to specifically manipulate one variable. This is referred to typically as your independent variable or your IV. And every experiment includes at least one DV or dependent variable. That's what you're measuring. So when you manipulate, in other words, when you change things, you do something to some people and another thing to other people, that's called an independent variable. And when you measure how they respond to it, that's called a dependent variable. Furthermore, when you think about the independent variable, it's critical that the manipulation, that IV, needs to differ between the experimental group and the control group. In other words, you need to do one thing to one group of people and another thing to another group of people. In addition to this, those two different groups, the experimental and the control groups, need to be independent from one another, meaning that group members or group membership doesn't influence an individual's results. In other words, we should never test the experimental group altogether and the control group at another time altogether. Why is that? Well, because it might be, let's say you give your experimental group a video of a Disney cartoon and you think this is going to make them happier. And you give your control group a video of paint drying and you think that won't make them happier. So you gather all your experimental group together in one room and you show them the Disney video. And all your other group together in another room, you show them the paint drying video. Well, let's say someone happens to laugh out loud to the Disney video. And then they start laughing so hard that they get the giggles and they start crying. And everyone else in the room could find the Disney video, they could take it or leave it, but they start to get giggly because of this other person who's losing it. In other words, now you don't know what's changing people's happiness. Was it the Disney video or was it being in the presence of someone who gets the giggles? Silly example, but that's one of the reasons why those two groups need to be independent from one another, meaning you should try to test someone or expose someone to your manipulation, your intervention, separate from other people who are being exposed to that manipulation. Furthermore, and I can't stress this enough, how important it is that individuals be randomly assigned to each group. In other words, the differences between groups is the only measure of our hypothesis, whether our manipulation does something. And if we have other variables that contaminate it, our findings will be useless. So for instance, instead of randomly assigning, let's imagine that we allow people to pick Monday or Friday. And the Monday people get the experimental manipulation, and the Friday people get the control intervention. We didn't randomly assign them. We let them pick Monday or Friday. Well, maybe the Friday people also happen to be procrastinators. They put this off. Now we don't know, are Monday people who are not procrastinators happy because of our experimental intervention? Or are they happy because they don't procrastinate and other things in their life go well? So it's really critically important that we randomly assign them. And finally, statistically significant results for a simple experiment involve a difference between means. And what we say is a difference between means that's not likely to be due to chance alone. So differences between